Hello everyone, I hope that I'm live right now. If you guys are able to hear me properly, please do let me know, guys. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly, please do let me know. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly, please do let me know. Good evening, everyone. Good evening. Okay, great. Amazing, guys. Amazing. So, how are you guys? Are you fine right now at your home or in your college? So, how many of you are still in your college itself? Like, even though pandemic is going on, you have been called off to like attend the classes offline in your college itself? In college, online. Okay, still in college. College at home, at home. Now I'm in college. Okay, so it's like 50-50. Some of you are in college and some of you are at home. Okay, no issue with that. So those who are in college physically, are you able to attend these type of boot camps on a regular basis? We would like to know from you guys that even though you are in college, if you are in college, not at home, are you guys able to attend these boot camps, these live boot camps from time to time? Okay. It's hard, but I'll do my best. Okay, that's great. That's great. That's why we do not keep the boot camps very long. We try to keep it as short as possible, so that you guys are able to understand it. And of course, all the video recordings of all the classes are also available online. You can refer to them at any point of time as well. So you do not have to worry about that. Okay. Okay, great. So we'll wait for 2 more minutes so that if someone wants to join us today, they can. And then we'll start with our today's class. Okay, so that will be the aim right now. Just waiting for everyone to join us so that we can get started. For just today, I have the class for 5:30. Okay, every day it will be at 6:30 itself. Sunday will be a holiday for you guys. Try to revise everything on Sunday. Okay, so keep that in mind. Today we are going to start with NumPy. It's a library in Python or numerical Python library. So there are various different mathematics. So in machine learning and deep learning, most of the computation that we will be doing will be in matrices. Okay, in the matrix format. Okay, so it may be a 2D matrix, a grid type of structure. It may be a 2D matrix. It may be a 3D matrix. So there is a lot of operations that you need to perform on these matrices. Now, by using the default Python is not that fast enough, and it does not has inbuilt functions that can be easily utilized to perform calculation on like matrices itself. So that is where the numerical Python or NumPy module of Python is being utilized. So that is what we will be seeing. Why it is being used, we will also be looking into that. So do not worry about the same. Okay. So that is what we are going to do today. Are you guys able to understand? Please do let me know. Okay, amazing guys. So let's get started with our today's class. In the description of the video, I have updated the notebook that we are going to use. The notebook that we are going to use is this particular notebook. You can find it in the description of the video. If you're not able to find it, refresh the page and then you will be able to find the link. Okay. So it contains everything. Okay, we have written it in a notes type of format as well, so that you guys are able to utilize it later on for revising things as well. Okay, so you can explore the entire notebook. If you want to like explore NumPy in a little bit depth, okay, what you can do is you can go to our GitHub page. As you're able to see, just click on right over here on ShapeAI. That will take you to our GitHub page. On that you will be able to find one of the notebooks. I think so this is the notebook, Python and machine learning. Okay, so no, this is not the notebook. Let me just find it. I also don't remember. Let's say maybe data analysis and machine learning. So no, this is not it. Python for data science. Okay, so right over here you have other notes just for Python that is publicly available. These have been made by ShapeAI. Okay, so for example, you want to learn NumPy in depth. Okay, so there are two notebooks that you can refer to: Day 5 NumPy Part 1 and Day 6 NumPy Part 2. So these are the two notebooks. It covers the entire NumPy that you need to learn to, like, that's over. Then the NumPy is over for you, can directly go on to the next topic. Okay, so NumPy Part 1, NumPy Part 2 and NumPy Part 3. So these are the three notebooks that cover NumPy to its core. So and it's entirely written in such a format that you are able to learn it as a notes as well. As you are able to see, everything is properly made and maintained as well, with new stuff that we are putting inside these notebooks. Every single time we get something that we think that it's extremely important for you, so you can just go into these notebooks, look at it, and I feel that you will be able to learn these topics very easily. The entire Python, okay, the entire Python has been covered right over there. So you don't have to worry about the same. So the name of the is Python for data science. Okay, Python for data science. We have made the entire thing in like 15 days or like 11 days itself, 13 days. So the total number of days is 13 actually. And you will be able to learn the entire Python, whatever that you want to learn, like from basics to intermediate to even advanced Python, you will be able to learn it from here itself. Okay, so if you and this is something that we use in our training program as well. So this is just for Python. We have the same for R, we have the same for SQL, we have the same for machine learning, deep learning projects, and many more things as well. So you can look into it, star it if you like. I think so no one, like, there's really less number of stars on this, but no matter what, okay, it's totally up to you guys. Try to look into it. If you want to contribute something to the same, you can contribute accordingly as well. Okay, so that's it. Let's start with NumPy. So again, in the description of our today's video, I put up the link to the notebook that we are going to use to learn NumPy today. Okay, so so you just have, what you have to do is you have to go to Google Colab once again. Okay, you don't have to do anything. You want to go to Google Colab, just give me a second. Okay, so some of you are saying that the like quality of the screen is you are not able to see it correctly. So I will just explain. I think so many of you are using YouTube for the very first time. No matter what, I thought that that would be like from the next time I need to put up that YouTube is a prerequisite for these boot camps. Okay, so from the next time I will put up that YouTube is a prerequisite for these boot camps. So you need to know how YouTube actually works. So what you have to do is extremely simple. You just have to go to your settings. You want to go to quality, okay, and then you want to change it to 1080p. That's it. Okay, so then you will be able to see the screen absolutely clearly. Anyway else, whenever I'm entering into the notebook itself, I will be increasing the font size of my screen as well. Okay, do not worry about the same. So again, in the description of the video, you will have a particular link. When you are clicking on that particular link, that is linked to the notebook, you will be taken to this particular page. on which we are having our notebook right over here. What you want to do is you want to copy the URL. Okay, you want to copy the URL of this particular page. So I'm copying the URL from right over here. Let me just copy it. So I've copied the URL from right over here. Then I will be going to my Google Collaboratory. From there, I want to select GitHub. Okay, we have examples, recent Google Drive, GitHub upload. We have to select GitHub. In GitHub, I want to paste the URL that I've copied, and then I want to go and click on search. Okay, so this will open up my notebook inside of Google Colab. Once I've done that, I want to click on connect. Okay, so that will connect me to the resources at a Google server. Once that has been done, we can then start with our NumPy. Okay, so are you guys with me right now? Please let me know in the live chat. Are you guys with me right now? Please do let me know. Okay, amazing guys. So let's get started with NumPy right now. Okay, so NumPy, as I've already said, stands for numerical Python. Okay, it's a fundamental package for scientific computing in Python. Okay, NumPy provides Python with an extensive math library capable of performing numerical computations effectively and efficiently. Okay, so that's basically a high functioning way of saying that it helps you to do maths in Python. Okay, that's it. So like think of it as a little mathematician that will sit with you to do all your calculations. Okay, so that is how NumPy actually works. So we will be giving you a basic overview of NumPy and introduce you some of the important features of the same that will help you to make the project and even understand the project as well. Okay, these are the two things that we'll be focusing upon. If you want to learn NumPy in a little bit depth, I've already shown you the like packages that we are having where you can go and do that. Okay, give me a second guys, I'm just switching off my screen for a second. Give me a second. Okay, I've done that purposefully, so give me a second guys. Okay, give me a second guys. Okay, give me a second. I think so this is almost done. I need to check something. Yeah, I know the screen is not visible. Like I said, give me a second. I need to check something first. It will take a second to give me that. Okay, so it's done. Okay, so I'm just switching on my screen right now. So let's continue with NumPy. Okay, so you might be wondering why people use NumPy after all. Python can handle lists, as you have learned in the Python lesson. So we haven't done that right now, but Python also has a list data structure. Okay, there's a data structure in Python called as list. For those who are familiar with arrays in other programming languages, Python lists also work in a very similar way to arrays. Okay, so the same way NumPy also has like arrays in the same. Okay, these are one-dimensional, two-dimensional matrices, or think of them as grids. Okay, that is where NumPy comes in. So okay, so what we are going to do is right now we are going to see why do we prefer NumPy over the default lists present in Python. We will be seeing what is the difference between the two. So what I've done here is I've imported two libraries or two packages. Okay, in Python you refer to them as packages. Okay, so we have imported two packages that is present in Python. The first package is time, as you are able to understand from the word itself. This particular packages provides you with the necessary tools, okay, necessary functions to handle time-based computations. Whereas NumPy, as we have already learned right now, that it is the numerical Python package that we are importing. So import NumPy, and NumPy is a very big term. I do not want to write NumPy again and again when I'm using the package. So I'm giving it an alias, okay, or a nickname. For example, my name is Priyanshu. So my nickname when I am in like my house is Piyu. Okay, in the similar way, we can assign an alias or a nickname to NumPy as well. Here the common default nickname to NumPy is NP. You can keep it as AD as well, that's totally up to you. You can keep it as anything, that's totally up to you as well. But the common practice is to keep the alias as NP. So right now I am importing time as well as importing NumPy as NP. So whenever I want to whenever I want to use the NumPy package, I will be writing the name as NP. Now what I'm doing is I'm creating a NumPy, think of it as a NumPy array. Okay, I'm creating a NumPy array of let's say how many zeros are there, 1 2 3 4 5 6 7 8 9. So what is this number, billion parameters? I guess it is a billion parameters, I don't know. So 9 is like 100 crores, I think so. So let us take up it as 100 crores itself. So I have made a particular array. Okay, so what I've done right over here is I have made a particular array, let's say in NumPy, that contains 1 0 0 1 0 0 1 0 0 elements inside of it. Okay, there are many number of elements present inside this particular array, and these elements, okay, I have used np.random.rand. Okay, so that basically tells NumPy, okay, that basically tells NumPy that I want 1 into 10 to the power 9 elements, okay, that are random at nature. So I don't know what is going to be here or what is going to be here or what is going to be here. All these elements are random in nature. So this can be 0, this can be 0.3, this can be 4, this can be 8. So these are randomly selected, and I have a list, I have an array, I have a NumPy array of 1 into 10 to the power 9 random elements. Okay, these are 100% random in nature. So what I'm going to do right now is I'm going to calculate the average of all the random elements present in that particular list or that particular NP array. Okay, so what I'm going to do is I'm going to calculate the average. Okay, so can someone let me know what is the formula of calculating average? If you are giving a list of numbers, okay, if you are given some numbers, okay, on your paper, how will you calculate the average of those numbers? Can someone let me know in the live chat? How will you calculate the average of a list of numbers that has been given to you? Can someone let me know in the live chat, please? Exactly, that's correct. So we will be sum divided by length. Okay, that is the total of all the numbers present in that particular list divided by the number of elements present in that particular list. Okay, so to calculate the sum of all the elements present in the list called as x, so we are having x is equals to np.random.rand. So x is the list that we are having. So if we want to calculate the sum of all the elements present in the list x, we have the formula sum x. Okay, this is how you do it using normal Python. Okay, I'm just talking about normal Python. Sum and in parenthesis x, so that will calculate the sum of all the elements, all the 1 into 10 to the power 9 elements present in the list x. I will divide it by the length of x. Length of x will give us the number of elements present in x. We have already seen length of a string gives us the number of characters present in a particular string. Similarly, length of x, that is length of a list, gives us the number of elements present in that particular list. And we will divide the two to get our average. Okay, we will divide the two to get our average. Are you able to understand? Please let me know up till this particular point of time. Are you able to understand or not? Please let me know. Are you guys able to understand up till this point of time? Please let me know, guys. Okay, okay. Okay, so what we are going to do right now is using this is how you do it in normal Python. So what we are going to do now is we are going to look at the time. Okay, so time is a particular like library that we had, the package that we had imported. So what we are going to do right now is to look at how much time does it take. Okay, so we are having a particular process that we need to do. Let us see at that. We need to perform a particular task. Okay, let's say it is a task task. Okay, the task 1. Okay, we want to check how much time it took us to run a particular task. So what you will do, you will look at the clock in the beginning of the time. Okay, that okay, now right now it is 8 p.m. Okay, you looked at the clock before the task started, and then once the task had ended, you will look at the clock again. So okay, the task ended at 9 p.m. So how much time did it take to run that particular task? You will just subtract these two values. Am I right? If you want to check how much time does it take to run a particular task, okay, how much time does it take to run a particular task 1, what will you do? First you will check what is the time before the task started, then you will check what is the time at the end of that particular task, and then you will subtract the two to get how much time did it take to run the task 1. Okay, as simple as that. So what we want to do right now is we want to come back to our screen, look at this code. So what does this code mean? Okay, according to you, what does this code mean? This code is taking the time at which this task started. So time dot time, okay, time dot time. Time is the name of our library, okay, that we have imported. Time is the name of the library that we have imported, and dot time method, okay, is the particular method that we are calling to get the current time, the time at which this particular line of code starts executing. Okay, it gets you the time, the exact time at which this particular line of code starts executing. So that is, for example, 8 p.m. Now the next line of code starts executing. Mean is equals to sum x divided by len x, so on and so forth. Next, what we do is again we look at the current time after. Okay, time dot time is after this particular line has run. Okay, so this particular time will give you the time 9 p.m. and start is a particular variable that has stored the initial time, the beginning time, that was 8 p.m. So you will just subtract the two to look at what is the result. You will subtract the two to look at what is the result. So when I'm running this particular line of code, we will get the time it took to run the mean, to the calculation of the mean code. Okay, it will give you the like mean, how much time it took to calculate the mean. Okay, so we are running this particular line of code, you will be able to see, okay, x is not defined. Okay, I forgot to run this particular line of code. Let me just run it. So NumPy is generating all the 10 into 10 to the power 9 numbers, random numbers right now. So that have been generated. Now we are calculating. Okay, now we are calculating the time right now. Yes, you will get the answers in second itself. You'll get the answer in seconds itself, guys. One more thing that you will be able to see is the RAM itself. Right over here, you will be able to see that almost 8.21 GB out of 12.69 GB has been occupied by this particular code. The third code that you ran, it occupied 8.2 GB right over there, because the list that you generated of 10 to the power 9 numbers, that list currently lives in your RAM, and 10 to the power 9 numbers is a huge amount of data that has been generated. So that's why your RAM has got filled up so fast. This is a YouTube video, guys. For those who are not able to listen to me or those who have joined late, you can rewind the entire video and watch again. Okay, no need to disturb the rest of the students who have come on time. Okay. So it's still taking time. It will take a lot of time, almost 3 minutes to complete running the entire thing. So you are able to see that even though you were doing a very small calculation of just calculating the mean of the numbers in a particular array, it is taking so much time to do that particular like execute that particular code itself. So you are able to see how slow normal Python is. If you are going by default Python libraries, default methods, you are able to see how slow it is. Okay. So the last line of code also takes some time to write. No, that is the thing. Time.time will give you the exact time at that particular moment. Now time.time is a particular function that gives you the time. Okay, it is not performing any calculation. It is just looking at your system clock and giving you the time. The time taken is in less than milliseconds. Okay, so that time is negligible when compared to the time that you are running the code. See, you are in fact getting the exact time it took to run this particular mean line itself. So don't worry about the same. Okay. Can Collab increase the RAM, or we need to use Anaconda if more RAM is required? You can increase by some methods, of course. You can increase the RAM up to 32 GB in Collab, but I feel none of you must be having a computer with more than 12 gigs of RAM. Collab provides you with 13 gigs of RAM, so that's more than sufficient for almost everything that you want to do. Okay, so as you're able to see, it took us 169.5 seconds. Okay, it took us almost 2.5 minutes to run this, more than 2.5 minutes to run this particular line of code. Okay, similarly, now what we are going to do is we are going to calculate the same, that is mean, but this time we are going to use NumPy for the same. So again, we'll be writing the same code. First of all, we are having the start of time. Then we are having our mean that we want to calculate. So mean np is equals to np.mean and then x. So that is the function that we are going to use to calculate mean using NumPy. Okay. 12.39 GB of RAM from the Google Colab server itself, not ours. Okay, it does not know which, like of course it knows which laptop we are using, but still, okay. So right over here, we have written this particular line, and then we are again looking at the time to calculate how much time it took to run this particular line. You will be able to see how much time it takes. I'm running this particular line of code and it has executed itself. And we are able to see that it took less than a second. Instead of taking 2.5 minutes, more than 2.5 minutes, it took less than a second to calculate the same thing that we were doing using Python. Okay, so that is the difference. The speed itself, the speed of doing mathematics in NumPy is far optimized, far greater than what it was in the traditional Python language itself. There are some new like libraries that have come up in the past 6 months itself. I was even working on one of those libraries that are even faster than NumPy. TensorFlow itself, but they have been developed for deep learning and not for machine learning. TensorFlow itself is continuously adapting to those changes itself. So there are some libraries that are even faster than NumPy, but NumPy is the standard in today's world. These new packages have been developed in the past 6 months, and does not has enough community to back it up or support it or to have real practical usage as of this particular moment. Okay. Okay. Okay, so let's move on to the next, creating NumPy ND arrays. Okay, so right now we have seen why do we require NumPy. Okay, we have already seen that that what is the requirement of using NumPy. So give me a second, guys. I'm getting a call. I will just answer that. Give me a second. Give me a second, guys. Okay, so let's continue from right over here. Okay, so now we are going to look at some of the important features of NumPy that you will be using. One of the main important things is, like I said, machine learning and deep learning is all about matrix multiplications itself, performing various calculation on matrices. So having matrices available to us with fast computation is extremely important, and for that NumPy has given to us ND arrays. Okay, so for those who are not familiar with arrays, think of it as grid type of structure itself. Okay, and n represents the dimension of that particular grid. Okay, so let us look at it from a drawing perspective. So for example, you want a one-dimensional grid, so it will look something like this. Okay, this is a one-dimensional grid, also called as 1D array. Okay, secondly, you are having a two-dimensional grid. Okay, so you are having a two-dimensional grid somewhat like this. These are called as 2D array. Okay, and similarly you have a three-dimensional grid, so that will look like something like this, and that will be a two-dimensional array, and so on and so forth. And these are all together called as ND arrays. Okay, in NumPy, these are called as ND arrays in NumPy. Please remember this. Okay. Okay. So there are two ways to create ND arrays in NumPy. There are using Python lists. Okay, you can use the inbuilt data like structure that has been given by Python, that is the list data structure, to create these type of grids. Or the second is you can use the NumPy functions. Okay, we have already seen that using NumPy function would be much more advantageous to us. Can someone let me know why should we use the NumPy function over the list function by Python for creating the ND arrays? Okay, can someone let me know in the live chat what is the reason for doing that? We have already discussed it multiple different times as well. Can someone let me know, please, in the live chat? Optimized time complexity, of course, because the list that is made by default in Python would be slow when compared to the list that will be created by NumPy. Okay, NumPy called them as arrays, and in normal Python we call them as lists. Okay, so let's look at this. So creating a list in Python is extremely simple. Okay, if you want to create a list, you just have to put up x is equals to 1 comma, let's say 1 comma 2 comma 3 comma 4 comma 5 comma 6. Okay, so this is how you create a list in Python. As simple as that. You have a list, you want to put everything, all the elements that you want to have inside that list into square brackets, and then you can put all the elements inside of it. As simple as that. Nothing too complicated. Trying to keep it as simple and light as possible. So now once you have created a particular list in Python, so you saw that it's very easy to create that. What about NumPy? How to create a particular array a NumPy array in Python. So for that, first of all, you will need to import NumPy, of course. So we are importing NumPy. So import NumPy as NP. NP is the alias. Then we are going to create a 1D array using a list. So what we are going to do right now is we are converting, okay, we are typecasting. So we have already learned about typecasting. We could typecast an integer to float, a float to int. Similarly, we can typecast a data structure as well. We want to typecast a list into an array and NumPy array. So for that, the code is np.array. Okay, that is to create a NumPy array. And then we are having inside rounded parenthesis the list. Okay, inside rounded parenthesis the list. Okay, so once we are printing it out, you will be able to see that it does not look different from the list itself. It looks the exact same way as the list appeared. As you are able to see, this was the Python list highlighted above, and this is the ND array, that is the NumPy array that we have created. So it looks the exact same way. The only difference is that ND arrays are faster when compared to normal lists in Python. Okay, once we have created a particular one-dimensional array, sometimes we may need to check the shape of a particular array. Okay, so what do I mean by that? What is the shape of a particular array? Let's try to understand it using these examples that we have made right over here. Let me just rub everything. Give me a second. Okay, so right over here, the shape of this particular ND array that we are having is basically the number of rows and columns that it contains. So it contains number of rows that it contains is 1. The number of columns that it contains is 1, 2, 3, 4, 5, 6, 7. So 1, 7 would be the shape of that particular ND array. Sometimes 1 is not written down, only 7 is written down, because it is understandable that you cannot have 7, 0. There's nothing like we have 7 columns and no rows. There is nothing like that. So you can ignore the 1, you can just write 7. Writing 7 means that there are 7 columns and 1 row. Similarly, if we take this 2-dimensional array, what will be the shape of this particular array? Can someone let me know what will be the shape of this particular array? Can someone let me know in the live chat? Can someone let me know in the live chat, okay, what will be the shape of this particular array? 3, 5. Great, everyone. 3, 5. Okay, that is number of rows are 3 and number of columns are 5. And similarly, as we go into n dimensions, we write the number of rows, we write the number of columns, we write the number of blah 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 blah, and so on and so forth. The height, the depth, okay, the 4th dimension, and so on and so forth. So that is called as the shape of a particular ND array. Okay, that is the shape of a particular ND array. So right now I have shown the attendance on the screen. Just take a screenshot after the end of the video itself. You can fill up the form, not right now. Do not fill up the form right now. Fill it at the end of the entire class. Okay. Okay, why 3, 5? That is 3 are the number of rows and 5 is the number of columns that are present. Let us look at that. 3 are the number of rows. As you are able to see from right over here, there are 3 rows. Okay, that is 3 is the number of rows and 5 columns. As you are able to see, there are 5 columns. That is 5 is the number of columns. So that is the shape of this particular ND array. Okay. Okay, great. So to check the shape of a particular ND array, NumPy array, what you have to do is, so what we are doing is we have created an ND array right over here. So x is equals to np.array, and then we have converted a list in Python to the ND array. Okay, so when we are printing x out, you will be able to see that x is equals to 1, 2, 3, 4. We have already seen, okay. So do we use 4-dimensional ND arrays? Yes, you will be using like n-dimensional, 12 dimensions, 19-dimensional ND arrays as well in deep learning and machine learning. Okay, so but there is no practical example right now, but yes, you will be using it. That's why it exists. Okay. Okay, so we have made we have created a one-dimensional ND array, as you are able to see. Okay, we have created a one-dimensional ND array. So Vaishnavi Pandey has asked, sir, but we start indexing from zero, I think. Yes, Python is a zeroth indexed element. Okay, so let us try to understand this. Okay, Vaishnavi has asked a very, I won't consider it as a good question because it's a practical question itself. So let's see right over here. We are having a particular society. Okay, we are having a particular society right now. We live in a society, and the society has many houses inside of it. Okay, there are various different houses inside the society. Now I'm going to number. So indexing, what is indexing? It is the number of the address of a particular house. Okay, so the first house is numbered as 0. So this is the 0 house, this is the 1 house, this is the 2 house, this is the 3 house. This is the address of the house. So if I'm asking a particular question, okay, how many houses are there? What will be your answer? Indexing is the address of that particular house. I have written the address as, that is the index, as 0, 1, 2, 3. But if I'm asking a question, how many houses are there? What will be your answer? Will it be 3 or will it be 4? Vaishnavi, this question is actually for you. I know rest of the students are able to understand this. Vaishnavi, please write your answer inside the live chat box. I'm waiting for your answer, Vaishnavi. Vaishnavi, please write your answer in the live chat box. Great. So that answers your question, Vaishnavi. Indexing is the address of that particular element. But the number of elements, okay, that is what is the number of rows or the number of columns. Okay, we are talking about number of. We are not talking about the index. Okay. Okay, great. Okay, so right over here, so what do you mean by index? So many people would not be familiar with the same. So let us try to understand this. So we have created a list, okay, of numbers. Let us write the numbers down. So that is 1, 2, 3, 4, and 5. So these are the numbers. These are the array that we have created. We are indexing, that is, we are giving an address to each of these numbers. So 1 is present at the address of 0. 2 is present at the address of 1. 3 is present at the address of 2, 3, 4, so on and so forth. So this is like Delhi. This is Mumbai. So this is like examples. Okay, these are the addresses at which they are present. Okay, these are the like addresses at which these elements are present. Okay, try to understand it like that. Okay. Okay, so that is basically indexing, and Python is a zeroth indexed element, language. So that's why we start the indexing from 0 and not from 1. Okay. Okay, so let's move on to the next question itself. The next part. So x.shape is the particular method that we use to find the shape of that particular array. Okay, we want to find the shape of that particular ND array, and you are able to see the answer that we are getting. X has dimensions of 5 comma nothing. That means 5 comma 1. That is 5 number of columns and no rows. Okay, 5 columns and no rows. Okay, so you are able to see that is like 1 row. That's why we are written nothing right over there, because it is understood that it is just 1 row right over there. So that's true. There are 5 elements and just 1 row. Okay, next we are able to see the type of the object X. Okay, what is the type of this particular object? So the type of this particular object is numpy.nd array. Okay, the type of that particular object is numpy.nd array. The next thing that we are checking is the data type what is the type of data present inside the ND array. Okay, what do you mean by D type? Data type, we've already seen data types yesterday: integer, float, string. So what is the kind of elements, the elements that are present inside that ND array, what is the data type for those elements? Okay, so there the data type is of int 64, that is integer data type in 64 bit. Okay, the number of bits that it can contain is 64. Okay, okay, so let's move on to the next thing. Okay, so what we are going to do right now is we are going to create the ND array, one dimensional ND array, okay, containing strings. There is no difference between the two. We are just changing the data type. We are changing the data type from integer to string. Okay, we are changing the data type from integer to string. Okay, so usually the time of the boot camps is around 6:30 in the evening. Sometimes it starts from 5:30, sometimes it will start from 6:30. Sunday will be a holiday. Okay, we will be having a holiday on Sunday. You guys can revise all the things that I have taught up till that particular point of time. Okay, do not worry about the same. Okay, so let's look at this right now. We create a rank 1 ND array that only contains string. Okay, so we print x, so you are able to see x is equals to hello world. Okay, that's totally fine, we have got it. Then we print the information about x. Okay, so x dot shape, so there is just two columns right over there, so 2 comma nothing, because we only have one row. Type of x, so the type of x is class and numpy dot nd arrays, so that is numpy dot nd arrays. X dot data type, so the data type of the elements present inside x, as you are able to see, is strings. Okay, so we will get u5, okay, or Unicode 5, that is the string data type itself. Okay, please try to remember that. Okay, so next what we are going to see is what will happen if we have mixed data types in the NP array. Okay, what will happen if we are having mixed data types in the NP array. So right over here we are having a list that contains both integers as well as strings. Okay, that contains both integers and strings. So when I'm running this particular line of code, you will be able to see that we get no problems from right over here, because Unicode 21, okay, contains both characters as well as strings in them. So we get it together. You do not have to convert anything from like integer to string or string to integer. That will be handled by NumPy. Okay, NumPy by default will convert all the integers present in the list to strings by themselves. You don't have to do anything. All the integers that are present in the list will by default be converted to strings. You don't have to worry about anything. Okay, so like we are doing right over here, when I'm running this line of code, you will be able to see that we get u25 Unicode 21 as the data type, that is a string data type. Okay, so that is how it works. So any number or even float, okay, even float, if you are putting up any float value as well, that too will be converted into string. Okay, that too will be converted into string. Okay, now we will be looking, okay, now we'll be looking at two-dimensional ND arrays. Right up till this point of time, we have discussed about one-dimensional ND array. We have discussed upon one-dimensional ND array of integers. We have discussed upon one-dimensional ND arrays of strings. We have discussed about one-dimensional ND arrays containing both, all three, strings, integers, and floats. So we have seen all these three cases in one-dimensional ND array. The same differences in data types can be carried forward to n dimensions as well, so we'll not be repeating over that. We'll just be checking on how can we convert, like how can we create a two-dimensional ND array. That is our aim right now. So let's try to understand this right over here. To create a one-dimensional ND array, what was the process? Okay, I want to create a ND array of 1 2 3 one dimensions. How we will do it? Okay, it will look something like this: 1 2 3. That's fine. We have a one dimensional ND array of 1, 2, 3. I want to create another one dimensional ND array containing 4, 5, 6. Okay, so I will again create a list 4, 5, 6. Okay, one dimensional ND array containing 4, 5, 6. I want to create another ND array containing one dimension itself, containing the characters 7, 8 and 9. So we are having another one dimensional ND array containing 7, 8, 9 right over here. Now if I want to convert this into a matrix, okay, if I want to convert this into a two dimensional ND array containing 1, 2, 3, 4, 5, 6, 7, 8, 9 like this, what I need to do is I need to consider each and every row, each and every element, each and every one dimensional ND array as an individual element itself. I want to create, so to create a two dimensional ND array, think of it in such a way, a two dimensional ND array is nothing else but an array of one dimensional ND arrays. Okay, if I'm calling this particular array as A, this particular array as B, this particular array as C, what is the two dimensional ND array? What is the two dimensional ND array? The two dimensional ND array is nothing else but A, B, C. To create the two dimensional ND array, we just have to write A, B, C. We have an array of arrays. Similarly, if we know how to write a one dimensional ND array, to create a two dimensional ND array, I have to do nothing. I have to put up a square bracket in the front, a square bracket in the back, and then put two commas right over here after A and right over here after B, and I've got myself a two dimensional ND array. As simple as that. To create a two dimensional ND array, I just have to create all the one dimensional ND arrays and then put all of them inside another ND array. That's it. I've got my two dimensional ND array. Now when I'm going to write it down in code, I will be writing the exact same thing as you are able to see from right over here. Let me just zoom in a bit. You will be able to see. Let me zoom in a bit more. We are having the first one dimensional ND array 1, 2, 3. The second n dimensional ND array 4, 5, 6. The third ND array 7, 8, 9. The fourth ND array 10, 11, 12. And then I have put everything. Okay, I have put everything inside. I have put everything inside the another array. That's it. Okay. We have done it. So this is how you can create a two-dimensional ND array as easily as possible. So when we are checking the shape of this particular ND array, so this is the array that we have created 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the shape of this particular array would be 4 number of columns, 4 number of rows and 3 number of columns. Okay, the shape of this particular thing would be 4 number of rows and 3 number of column. Okay, we can even check the size. Okay, size is the number of elements present inside the array. Okay, y dot size will give me the number of elements present inside the array. So as we are able to see, there are 3 into 4, that is 12 elements present inside the array, and we are having 12 elements printed out as well. The class is np.ndarrays as you are able to see, and the type is int64. So it is as simple as possible to understand. Okay, are you able to understand up till this point of time? Please do let me know, guys. Are you able to understand up till this point of time? Please do let me know. Great. So now we will be looking into some of the different data types. We will be using different data types to create the list. Okay, so this is not something that we need to discuss in depth. Just to show you guys that we have a list of integers. Okay, we have a list of floats. Okay, but when we have a list of both integers as well as floats, then it gets changed into float itself. Okay, it gets changed. All the integers present in the list gets changed to float. Okay, to store it. Okay, so that's why you will be able to see that the data type is of float 64. Okay, So one thing, please remember, in a list, in a normal Python list, you can have different data types in a single list itself. Okay, you can have integers, you can have floats, you can have strings, you can have more lists inside a particular list in Python. But when you're talking about ND arrays, okay, or NumPy arrays, then you can only have a single data type for the entire ND array itself. That's why if you are using lists of various different data types, it will get converted to a single data type. So if you are having a list of integer as well as float, it will get converted to float. If you have integer, float and string, everything will get converted into string, and so on and so forth. Okay, great. So let us see what we want to do right over here. So one more thing is, so right over here, as you are able to see, when I was creating this particular list, okay, of 1, 2.5 and 4, NumPy automatically converted, typecasted everything into float. Okay, but sometimes we don't want that. Sometimes I want all the elements to be, if there is a float in the thing, I want it to be get converted into integer itself. So you can even set up, okay, the data type for that particular list. Okay, for example, right over here, if I'm creating an NP array of all floats, like I'm having various different floats in the entire list, I can change the data type to integer. So d type is equals to np.int64. So while declaring the np.array, so np.array, while creating the np.array, I can even set the data type of all the elements in my np array, and you will be able to see that all the elements have now been typecasted into integer because I mentioned it. Okay, so if it was default, by default it would have been float, we will have got decimals, but we don't want that. So I have typecasted it, explicit typecasting. This is called as explicit typecasting. I've explicitly typecasted the entire list into integer. Okay, so that is also something that you can easily do. Oh, okay, the next thing that we are going to see, right, yeah, explicit typecasting. Okay, so I will not take up a lot of time. We'll keep it up till here. Tomorrow we are going to complete the entire NumPy. Day after tomorrow we are going to start with pandas. We will be starting with machine learning after that. It may be possible that we may extend the bootcamp by 1 or 2 days, okay, just to complete everything properly. So it may be the case that the bootcamp goes on for 9 days. Okay, so please bear with me. I want everyone to be very comfortable with all the topics. I don't want to rush anything, so that you guys are able to understand everything after the entire bootcamp ends. Okay, so that's beneficial for you as well, because even though I'm taking 2 days, I will be teaching more to you. Okay, so thank you so much guys for attending the bootcamp today. Again, like, it was great to meet you. We will meet tomorrow again around 5:30 or 6:30. Sunday will be a holiday. Please remember that Sunday will be a holiday. Okay, thank you so much guys. Have a good day ahead. Thank you.